Gently close your eyes. Relax your shoulders. Relax your arms. Relax your legs. There is no need to think too much. Just listen to my voice as it carries you to a place far, far away. Right now you are lying comfortably, feeling the softness of your bedsheet, the warmth of your pillow. With every breath you feel lighter and lighter, more and more relaxed. Tonight, let us go together and look at a star that is so very bright and so very beautiful. That star is Venus. Venus is the brightest star in the night sky, apart from the moon. No other celestial body shines brighter than it. Why is it so bright? Because its surface is covered by a very, very thick layer of clouds. These clouds can reflect 70% of the sun's light back into space. 70%. Just imagine, out of every 10 portions of sunlight shining onto it, 7 are reflected back out. No wonder it is so dazzling in the night sky. In ancient times, humans had already noticed this brilliant star. The Babylonians gazed at it and named it Ishtar, the goddess of love in their mythology. The ancient Egyptians watched it and observed that its appearances and disappearances followed a very regular pattern. The ancient Chinese also looked up at it and called it the Grand White Star. When it appeared in the east at dawn, they called it the Morning Star. When it appeared in the west at dusk, they called it the Evening Star. The ancients did not realize that the star seen at dawn and the star seen at dusk were one and the same. They thought they were two different stars. This beautiful misunderstanding persisted for a very, very long time. The Maya civilization was even more remarkable. They created a highly detailed Venus calendar to predict the planet's position in the sky. Their calculations were so precise it is hard to believe. Thousands of years ago, without any modern instruments, relying solely on their own eyes and their own wisdom, they could accurately forecast the motion cycle of Venus. Just imagine. On some night, thousands of years ago, a group of Maya astronomers stood atop a pyramid, gazing up at the starry sky. All around was very, very still. You could only hear the sound of insects calling from the jungle. They watched Venus slowly rise above the horizon, radiating dazzling light against the dark blue night sky. With tools made of stone, they carved the time and position of each appearance of Venus into stone tablets. Year after year, generation after generation, they passed these precious observational records down. What would they have felt in their hearts? Was it the same feeling we have today, that the universe is truly so mysterious, so beautiful, so worthy of a lifetime of exploration? Now try to imagine that you are one of those ancient people from thousands of years ago. You stand upon a vast open field. You lift your head and gaze at the night sky. Overhead stretches the Milky Way, crossing the entire horizon. All around, countless stars twinkle and shimmer. Among all these stars, there is one that is especially bright, especially dazzling. That is Venus. You gaze at it and feel as if it is speaking to you, telling a story about the universe, about time, about life itself. You feel so calm, so peaceful. The entire world grows quiet. It is just you and this star. The position of Venus within the solar system is the second planet from the Sun, right behind Mercury. Its orbit and Earth's orbit are right next to each other, neighbors. The distance between the two orbits is closer than that of any other two planets. So Venus is also the nearest planet to Earth. Sunlight takes 8 minutes and 20 seconds to reach Earth, but it only takes about 6 minutes to reach Venus. Think about it. Every ray of sunlight you feel here on Earth was emitted from the surface of the Sun more than 8 minutes ago. Those rays have traveled across 150 million kilometers of space before arriving at your side. That very same ray of sunlight, if it were heading toward Venus, would have arrived more than 2 minutes earlier. Time and light on the scale of the universe flow in just this way. They do not hurry. They do not rush. They simply follow their own pace, quietly passing through the endless darkness. From very, very far away, Venus and Earth look like a pair of twin sisters. Its diameter is 12,104 kilometers. Compared to Earth's 12,742 kilometers, it is only about 600 kilometers smaller, approximately 95% of Earth's diameter. Since the diameter is a little smaller, its volume is naturally a little smaller too. The volume of Venus is about 80% of Earth's volume. In terms of mass, Venus is about 81.5% of Earth's mass. Its gravitational acceleration is 90% of Earth's. That means if you weigh 100 pounds on Earth, on Venus you would weigh about 90 pounds. Walking would feel a little lighter. Jumping up would feel a little higher. As for density, because both are rocky planets, Venus' density is also very similar to Earth's. In the solar system, it ranks third, just behind Mercury. It is much denser than Mars and the four gas giant planets. Its internal structure is also the same. An iron core, a mantle, a rocky crust. Looking at these numbers alone, Venus truly seems like a slightly smaller version of Earth, Earth's twin sister, a reflection of Earth gifted by the universe. But when you slowly move closer and take a careful look, you will discover that these two sisters have completely opposite personalities. The true face of Venus is a world that is utterly different from our Earth. Rather than calling it Earth's sister planet, it would be more accurate to call it Earth's opposite. Now imagine yourself sitting on a spaceship slowly flying toward Venus. From a distance, Venus is a very bright, very white planet, completely enveloped by a thick layer of clouds. You cannot see its surface. All you can see is a layer of white cloud with a faint yellowish tint. This cloud layer is very smooth, very even, like a perfect pearl floating in space. But as you get closer and closer, you will discover that this cloud is not as gentle as it appears on the surface. The atmosphere of Venus is truly very thick and very heavy. Its atmospheric density is 93 times that of Earth's. The atmospheric pressure is 92 times that of Earth's. Try to imagine this pressure is approximately equal to the pressure at a depth of 1,000 meters in Earth's ocean. If you stood on the surface of Venus, it would be like having a column of seawater a kilometer deep, pressing against every inch of your skin, your entire body. On every square centimeter of area, hundreds of kilograms of weight would be bearing down. Any object entering Venus' atmosphere must withstand this almost unimaginable pressure. Moreover, the composition of this atmosphere is completely different from Earth's. 96% of Venus' atmosphere is carbon dioxide. There is also about 3% nitrogen and about 1% other gases. Carbon dioxide is a greenhouse gas. It traps heat inside the atmosphere, preventing it from escaping. Sunlight shines onto the surface of Venus. After the surface absorbs the heat, it radiates infrared light outward. But this infrared light is absorbed by the carbon dioxide and trapped inside the atmosphere, unable to escape. Because of this, the surface temperature of Venus soars to over 472 degrees Celsius, the hottest planet in the entire solar system. Just think about it, 472 degrees. The melting point of lead is 327 degrees. That means lead on the surface of Venus would melt the way ice melts on the surface of Earth. The boiling point of zinc is 907 degrees. While it would not necessarily boil, many metals at this temperature would become soft and mushy. The entire surface of Venus is one gigantic high-temperature furnace. Nothing can maintain its solid integrity at this kind of temperature. Even the hardest rock would be baked by this relentless heat until it glows red and softens. Mercury is closer to the sun, but it has no atmosphere to help it retain warmth. So the day-night temperature difference on Mercury is enormous. It can reach 430 degrees during the day and plunge to -180 degrees at night. But Venus is different. That extremely thick layer of atmosphere acts like a very, very thick quilt, trapping all the heat inside and never giving it a chance to dissipate into space. And so on Venus, no matter if it is day or night, no matter if you stand at the equator or at the poles, the temperature is the same, always that high. It never cools down. There is never a moment of cool relief. Just imagine a world that is forever at over 400 degrees, no crispness of morning, no cool breeze of dusk, no cold of winter, no freshness of autumn, only the endless, eternal, suffocating heat. At an altitude of about 45 to 70 kilometers above the surface of Venus, there is an especially distinctive layer of clouds. These clouds are not the white water vapor clouds we see here on Earth. They are a cloud layer made of sulfuric acid droplets. Sulfuric acid. Just think about it, in a laboratory. It is a highly corrosive liquid that must be handled with the utmost care, and yet on Venus, it is the main component of the cloud deck in the sky. These sulfuric acid clouds are intensely corrosive. Anything that comes into contact with them will be slowly eaten away, slowly dissolved, and the wind speeds within. These cloud layers are incredibly fast, reaching up to 360 kilometers per hour. What does 360 kilometers per hour mean in real terms? On Earth, the strongest Category 5 hurricane has sustained winds of over 250 kilometers per hour, but the wind speed at the top of Venus cloud layer is far faster than even that. When you look down from space, that white or yellowish layer is the sulfuric acid cloud deck. However, there is a very interesting phenomenon. These sulfuric acid droplets never actually land on the surface of Venus. During their descent, the sulfuric acid rain encounters increasingly higher temperatures as it falls. The over 400-degree heat of Venus' surface causes the droplets to evaporate completely long before they ever reach the ground. They turn back into gas and rise back up to the cloud layer. Then they condense into droplets again within the clouds and begin their descent once more, and so it goes, forming a cycle that never ends. It is like a wish that can never be fulfilled, the raindrops forever reaching for the ground but forever unable to reach it. These sulfuric acid clouds also play another very important role. They help to retain heat. They block the heat of Venus' surface from radiating outward, just like the glass of a greenhouse locking all the heat inside. And so on Venus, there is no change of the 4 seasons. There is no difference in temperature between day and night. It is always forever a world of hellish heat. By this point, you may be starting to wonder, what is a day like on Venus? The truth is, the rotation of Venus is very special and unique. Most planets in the solar system rotate counterclockwise. That is to say, from west to east, with the sun rising in the east and setting in the west. But Venus and Uranus rotate clockwise. The tilt of Uranus' rotational axis is about 177.4 degrees, so it is almost spinning completely on its side. Venus, on the other hand, is the only planet in the solar system whose rotational period is longer than its orbital period. It takes 243 Earth days for Venus to complete one rotation on its axis, but it only takes 225 Earth days for Venus to complete one orbit around the Sun. That means on Venus, a single day and night is longer than an entire year. A full year has come and gone, and yet a single day still has not finished. Try to picture it. If you stood on the surface of Venus from sunrise to sunset, you would have to wait a full 117 Earth days. 117 days. By then, nearly 4 months have already passed on Earth. Over this impossibly long stretch of time, the sun would rise slowly, slowly from the western horizon. Its rising speed would be extremely slow. You would need a great deal of patience to wait and watch as it climbs inch by inch above the horizon. Then it would hang there in the sky, radiating a piercingly bright light, and then after a very, very long time, it would finally begin to sink slowly toward the eastern horizon. Even after the sun has set, you would have to wait another 117 days before it rises again, and there is more, because the direction of Venus' rotation is the opposite of Earth's. The sun on Venus rises in the west and sets in the east, completely the reverse of what we are used to on Earth. If one day you could travel to the surface of Venus, you would see the sun slowly emerge from the western horizon, and then, after 117 days of endlessly long daylight, slowly disappear into the eastern horizon. Truly, it is a dreamlike, almost surreal kind of sight. Close your eyes now and slowly imagine this scene. You are standing on the plains of Venus. All around you are rust-colored rocks. The sky is yellow, covered by the thick sulfuric acid cloud layer. The sun has just begun to rise slowly from the western horizon. Golden light filters through the clouds, staining the entire sky with a soft wash of gold. There is no wind beside you, no sound, nothing at all that stirs or moves. Everything is still. Only the sun moves with the most extreme slowness. Time in this place seems to have fully stopped. 1 day equals 1 year. 1 year equals 1 day. You do not need to rush. You do not need to hurry, because in this world, nothing at all is fast. Everything is this slow. This slow. The surface structure of Venus is very different from Earth's. 70% of Earth's surface is covered by oceans, but on Venus, there is no ocean. There is no liquid water, not a single drop. Most of its terrain is plains, vast, unending plains made of volcanic rock. Besides the plains, Venus has 3 major highland regions. You can think of these highlands as being similar to the continents on Earth. The largest of these continents is called Aphrodite Terra. The name comes from the Greek goddess of love in keeping with Venus goddess imagery. This continent is located near the equator of Venus. Its surface area is roughly the size of the continent of Africa on Earth. Just imagine a landmass the size of all of Africa quietly floating on the surface of Venus. Nobody even knew it existed until it was finally detected by human radar. The entire continent is covered with traces of volcanoes and lava flows, like an enormous natural sculpture park. The second continent is called Ishtar Terra. The name derives from the Babylonian goddess of love, once again connected to the symbolic meaning of Venus. This continent is located in the northern hemisphere of Venus, near the planet's north pole, with an area similar to that of Australia. The highest peak on Venus stands here on this continent. It is called Maxwell Montes. This mountain is, in fact, a colossal volcano. Its height reaches 11,000 meters. 11,000 meters. Consider that the highest peak on Earth, Mount Everest, is 8,848 meters. This mountain on Venus stands more than 2,000 meters taller than Mount Everest. However, because Venus has no liquid water and thus no sea level, the concept of altitude is slightly different there than on Earth. If you apply Earth's standard of measurement, its height above the surrounding plains is actually similar to that of Mount Everest, but by any standard it is an immensely majestic peak, standing tall in the northern hemisphere of Venus, ringed by the surrounding volcanoes and plains. Venus is home to tens of thousands of volcanoes, more volcanoes than any other planet in the solar system. Try to picture it. Tens of thousands of volcanoes scattered across the surface of Venus. Some are very tall and very large. Some are shorter and flatter. Some have lain dormant for a very long time. Some may still be active. Are there still active volcanoes there? Scientists are not yet entirely certain, while there are some signs that suggest Venus may have active volcanic activity. For instance, changes in thermal radiation have been detected in some regions. The evidence is still not conclusive. More research and exploration are needed. Perhaps one day a human probe will see with its own sensors a volcano erupting on Venus, witnessing molten rock burst forth from beneath the ground and flow across the planet's scorching surface. The third continent is called La Terra. It is located near the south pole of Venus, among the three continents. It has the most complex terrain and is the smallest in area. Scientists have studied this continent the most because they speculate that there may still be some ongoing active volcanic activity here. The terrain of this continent is extremely rugged, crisscrossed with many ridges and canyons, as if a giant had sliced it up wildly with a knife. Aside from volcanoes and continents, the surface of Venus also has about 900 impact craters. These craters are all quite large, none with a diameter smaller than 3 kilometers. Why are there no small craters? Because any meteoroid that is even a little bit small, with a diameter smaller than 50 meters, has absolutely no chance of piercing through Venus' thick layer of atmosphere as it enters the Venusian atmosphere. The intense friction with the gas generates extremely high temperatures, and the object burns up entirely before it can even reach the ground, turning into a wisp of ash or a tiny shooting star, never having the chance to leave any mark whatsoever on the surface. That thick blanket of atmosphere on Venus is like a suit of protective armor, shielding Venus from all of the small impacts. But for the big meteoroids, this protective suit is not quite strong enough. They power through the atmosphere and smash into the ground, leaving behind one gigantic crater after another. Speaking of magnetic fields, here too, Venus and Earth are very different. Earth has a strong, internally generated magnetic field. This magnetic field protects our atmosphere from being stripped away by the solar wind. Without this magnetic field, Earth's atmosphere would slowly be eroded by the solar wind, just like what happened to Mars, a planet that may once have supported life, reduced to a barren desert. But Venus has no intrinsic magnetic field, at least not the kind of strong magnetic field that Earth has. Scientists speculate that this may be because Venus rotates too slowly. The liquid iron core inside cannot generate enough convective motion, so it is unable to produce a strong magnetic field. So the strange thing is, without a magnetic field for protection, why has Venus' atmosphere not been blown away by the solar wind? It turns out this is the result of several factors working together. First, the lack of a magnetic field means that the Venusian atmosphere is directly exposed to the solar wind. The solar wind blows continuously from the surface of the sun, carrying vast numbers of charged particles, hurtling through space at extremely high speeds. When the solar wind reaches Venus, the Venusian atmosphere does suffer some degree of loss. It is not completely lossless. Some of the lighter gaseous elements, such as hydrogen, have been almost entirely stripped away by the solar wind. This is why there is practically no water vapor in Venus' atmosphere. What remains is almost all the heavier carbon dioxide. The second reason. Every planet has a critical speed called the escape velocity. This is the minimum speed an object must reach to break free from the planet's gravitational pull. Earth's escape velocity is 11.2 kilometers per second. Venus' escape velocity is 10.36 kilometers per second. Although it is a little lower than Earth's, it is still quite high. Carbon dioxide molecules are relatively heavy, so reaching this escape velocity is not easy for them. Thus, carbon dioxide can remain within the gravitational grasp of Venus and does not escape all that easily. Third, although Venus has no intrinsic magnetic field, the interaction between its atmosphere and the solar wind creates an induced magnetic field. The way this magnetic field forms is different from Earth's. Earth's field is generated from the inside out, whereas Venus is generated from the outside in. When the solar wind crashes into the upper atmosphere of Venus, it ionizes the atmospheric particles and creates a conductive ionosphere. This ionosphere induces a magnetic field. Although it is very, very weak, something is still better than nothing. To a certain degree, it does help to resist the solar wind and slow down the rate of atmospheric loss. So rather than calling Venus Earth's sister planet, it is better to call it Earth's opposite. From far away, they look so alike, but draw near and you see they are completely opposite worlds. Earth has oceans. Venus is so arid there is not a single drop of water. Earth has a temperate climate. Venus is hot enough to melt lead. Earth has a rapid rotation. Venus rotates so slowly that a single day is longer than a year. Earth has a strong magnetic field for protection. Venus has almost no magnetic field. Earth's sky is blue, Venus' sky is yellow. On Earth, life flourishes and thrives. The surface of Venus is completely still and lifeless. Earth and Venus, they are like a mirror held up by the universe, each reflecting the opposite of the other. Humanity's exploration of Venus has gone through a very, very long history. From the ancient people thousands of years ago gazing up at the starry sky with their naked eyes, to Galileo discovering the phases of Venus through his telescope, to the 20th century when humanity began launching probes to explore Venus. Every step is a manifestation of the human desire for knowledge. Every step is a gentle inquiry that humanity has posed to the cosmos. During the ancient observation phase, humans could only look at the sky with a pair of eyes. The Babylonians had written records about Venus dating back to around 1600 BCE, recording the motions of the planet on clay tablets. The ancient Egyptians observed that the appearance of Venus was closely related to the position of the sun. The ancient Greeks knew that the morning star seen at dawn and the evening star seen at dusk were in fact the same star. The ancient Chinese called Venus the Grand White Star and used its positional changes to forecast the seasons and formulate calendars. The Maya were even more remarkable. They created a highly detailed Venus calendar that could accurately predict the planet's position in the sky with an incredibly small margin of error. Moving into the telescopic observation phase, the most pivotal figure was Galileo. In 1610, Galileo aimed his homemade telescope at Venus and discovered that Venus exhibits phase changes similar to those of the Moon, sometimes appearing as a crescent, sometimes as a half disk, sometimes nearly full. This discovery was extremely important. In the geocentric model, Venus was supposed to always be positioned between the Sun and the Earth, meaning humans should never have been able to observe the phase in which Venus was fully illuminated by the Sun. The phase changes of Venus were direct proof that Venus orbits the Sun and not the Earth. Combined with Galileo's earlier discovery of the 4 large moons of Jupiter, these two observational results together completely toppled the geocentric theory that had dominated human thought for over 1,000 years, confirming that Copernicus' heliocentric theory was the correct one. Breathe slowly, sleep well, sweet dreams. The next part will continue the story of Venus exploration.